Can you imagine a robot smaller than a grain of sand? No, I mean way smaller, tinier than the period at the end of a sentence. For decades, since the very first Macintosh computer came out in 1984, scientists have been trying to build autonomous robots this small, and guess what? They've finally done it. These new robots, developed by researchers at Penn in Michigan, are just 250 micrometers wide. To put that in perspective, that's about the width of a single human hair. They're so small you can't even see them with your naked eye. But here's where it gets truly wild. These aren't just tiny specks. They are fully functional robots with onboard computers, sensors, actuators, and power systems. It's like cramming an entire nervous system into a space that's practically invisible. So, how do they move? No tiny legs or propellers here. They create tiny electrical fields around them that push water molecules, allowing them to swim without any fragile parts. And their power source? Light. They can swim for months, powered only by ambient light. Even light so dim, it can pass right through human tissue. And how do they talk to each other? Well, they have a kind of microscopic sign language. They perform programmed wiggles and movements that scientists can watch through a microscope. It's like they're doing an interpretive dance to transmit data, like temperature readings. They're rewriting what autonomous even means. This is a huge leap, because traditional robotics always assumed you needed space for processors and batteries. But these tiny machines prove that computation can be ambient. They process information through their entire structure. Much like a single living cell manages to stay alive without having organs, in previous experiments, these robots even showed they could electroplate metal onto their own bodies. They can literally grow and bond together, self-assembling into larger structures like microscopic cyborgs. It's mind-bending stuff. Now, let's talk about cost. Right now, the prototypes cost about $10 each. But with mass production, that price could plummet to just 1 cent per robot. 1 cent. Imagine deploying a swarm of millions of these for the price of a used car. This opens up incredible possibilities. What really gets me excited is the swarm potential. Let's picture releasing millions of these into the groundwater to map contamination in real time, or imagine them in our bloodstreams, where they could self-organize into diagnostic networks to find diseases early. They aren't just tiny robots, they're becoming programmable matter. This could be the first step toward a future where intelligence is unconfined to a single device, but is everywhere and nowhere at once. It's dissolved into the very fabric of things. We're literally watching the birth of systems that can think collectively, without any single robot even knowing it's part of a larger intelligence. The future is getting very, very small and incredibly powerful. Thanks for watching. If you found this as fascinating as I did, hit that like button and subscribe for more mind-blowing science.